Today's problem is longest palindrome. It's an easy problem. Given a string S which consists of lower and uppercase letters, return the length of the longest palindrome that can be built with these letters. A palindrome, if you don't know, is a string that reads the same backwards and forwards. So ABA is a palindrome. ABBBA is also a palindrome. Letters are case sensitive. For instance, A small letter and A capital letter is not considered palindrome. Example 1. Input S equals ABCCCCDD. The output is 7. Why? The longest palindrome that can be built with this input over here is DCCACCD. So backwards and forwards, exactly the same. So essentially what we want to do is to take letters from the input. We can use as many letters as we want. We can shuffle them however we like to form a palindrome. And we form the longest possible palindrome we can. Example 2, as input is A, output is 1. It's already a palindrome, there's only one letter, so there's only one choice. If you were given a bunch of letters and you're supposed to rearrange some number of them to make a palindrome, how would you do it as a person? Don't immediately jump to data structures or algorithms or any of those things first. Just think about how you would solve this as a human being. Then we'll use those other things to augment our algorithm. I'm given the following string A, B, C, 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 D, D, and I want to make a palindrome from it. Well, the first thing I would think of is, okay, a palindrome has to have the same letters going forwards and backwards, right? So I want the first and last character to have the same character. Let's say I put D and D at the two ends. Inside is another palindrome, then I know that this would read the same backwards and forwards. Probably I'll look for another pair. Let's say C and C. Once we reach the middle, you don't need the middle to have two identical characters. So I might form a palindrome that looks like this: DCCBCCD. And this A here is the leftover. I don't know what to do with the A. We've learned two things. 1, if we can keep pairing letters off, we can keep adding to the palindrome. And 2, we can put any letter we want in the middle if we have spare letters left. So let's go back to a question a little bit and see what exactly we're required to do. So we're required to calculate the length of the longest palindrome, right? We don't actually have to return what the longest palindrome is. In fact, there's no one longest palindrome. Their palindrome is different from mine. How do we calculate what the longest palindrome is based on this information we have here? How do we calculate what the longest palindrome is? We can simply pair them off. Since there are 4 C's, we can pair these two with these two, these two with these two, and these two with these two. That when we take one of these and put it at the beginning, we'll put the other one at the end. For the middle letter, we can just pick anybody who's left over. Let's try an example with an odd number of characters. We switch this C to a D, so we have 3 C's and 3 D. We apply the same strategy as before. We pair each letter off until we're just left with singletons. Here, A, B, C, and D all have singletons. And we can pick any of one of them, let's say D, giving us the palindrome C, D, 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 C. Now to calculate the length of palindrome, we should first start by calculating the number of occurrences of each character. A appear once, B appear once, C appear 3 times, and then D appears 3 times. How many of these can be paired off? A, since it's singleton, none of them can be paired off, is 0. Likewise for B. C, there's 3, so 2 of them can be paired off. And D, there's 3 of them, 2 of them can be paired off. So a total of 4 characters in the pair, and then we add 1 more in the middle. This middle character can be anybody, so if there's at least 1 spare, there's 1, 2, 3, 4, 5, 6, 8 characters. We've only used 4 of them. We're gonna add a +1 equals 5, and 5 will be the answer for this example. Let's turn that into code. The first thing we're going to do is count how many times each character appears. We have some kind of frequency table, and we're going to make this a dictionary in Python. You can use a hash table in Java, it doesn't matter. And we're going to go through for C in as each character, we're going to increase its frequency by 1. Okay, that's the first part. Step 2, we're going to count how many pairs of characters are there. We're going to initialize a count equals to 0. We're going to go through all the counts that we have before. Let's just call this C for count, freq.values. So here we can actually ignore what letter it is. We only need to know how many times it occurred. So for C, if C is an even number, then count plus equals to C. Else, if c is an odd number, then count plus equals to c minus 1. So for instance, in our previous example, there was 3 occurrences of our letter D. Only 2 of them can be paired off. Okay, finally, if there are letters left over, use one for the middle. If count is less than length of s, so there's at least 1 letter left over, count plus equals to 1. Return count. So notice how we never actually construct any palindromes at all. We just use some math to figure out what's the longest palindrome we can construct. And now we submit. And this should work. Alright. It beats 98.18% of users with Python 3. So this seems pretty good to me. This is also coincidentally my 100th continuous daily challenge problem. Let me know in the comments what your longest daily problem challenge streak is. And as usual, if I enjoy my content, throw me a like and subscribe. And come check out our weekly contest streams every Saturday and Sunday. And come code along with me. This is Alex Does LeetCode.